Welcome back to my online teaching platform. We have a problem here, and I would like us to find the solution to this particular problem. We have to evaluate the limit of square root of x plus h or minus square root of x divided by h as h approaches 0. So it means here our input is h. Our input is what? H. So x here is considered as a constant. So how do we go about it? Let us deal with the direct substitution and see if we are going to get a defined expression. Let us start with that one and see what we'll be getting. So let us work with the direct. So we are going to get square root of wherever you see x, you put 0 over there. So it's going to be x plus 0 minus square root of 0. Then we are going to get here to be 0. So the moment the denominator is equal to 0, it implies that the expression is what? Undefined. The expression is, so what we have here is undefined. So we need to use the rationalization approach. Is undefined. So we cannot use this one to evaluate. Cannot use it to evaluate. So need to use a different approach. All right. So let us look at the best way of getting the limiting value of the expression or the radical function as its input h approaches 0. Let's look at how best we can evaluate it without getting undefined expression. So we are going to apply the concept of rationalization here under set. So we will apply it here. Right, so let us look at how best we can apply it and see if we can now get the right answer. So our problem is lim of square root of x plus h minus square root of h as h approaches 0, then all over h. So the moment you have it in this form, you can see that here the radical side is rather the numerator. So we are going to rationalize using the conjugate of the numerator. So this becomes square root of, so let us repeat it and move another step down and write it over there. So this becomes to be equal to lim square root of x plus h minus square root of h all over h as h approaches 0, and this will multiply the conjugate form of the numerator. So it's going to be square root of x plus h. So here becomes plus square root of h instead of minus square root of h all over same thing, square root of x plus h plus square root of h. All right. So we need to put them in brackets. So put this in bracket. Put this in bracket nicely. So this also in bracket then. Also put this in bracket nicely as I'm doing. Right, so we are multiplying. So let us now multiply. So we are going to get lim as h approaches 0. Then here we will be having square root of x plus h minus square root of h multiplying the other numerator, which is square root of s plus h plus square root of h. All right, you got the line nicely. So that one will now be h multiplying the denominator of the other fraction, which will be square root of s plus h plus square root of h. So I'll bring the bracket down. All right. So we continue to evaluate. So we are going to get length as s approaches, as h rather, not s, as h approaches 0. So you could start at the expression 7 as the numerator has difference of two squares. So we take the first one, which will be square root of s plus h, then squared minus square root of h, also in one bracket, then you square it nicely, all over h multiplying square root of s plus h plus square root of h. Close your bracket nicely, then we continue to work on it. So this will lead us to length. So when you take square of the square root of x plus h, it's similar with x plus h because the square here cancel the square root over here. So we are left with x plus h, then minus. Now this square also cancels the square root over, so we are left with only h. Oh, sorry, I think here is rather, let me correct it. What you have here, there is rather x, so let's correct it. Not h. Here too should be. So yeah, everything it should be. Here too should be x rather not h. So yes, so is here too should be x rather not h. Okay, let me correct all. Yes, x. It will be x. Yes, our x. All right, so I've done the correction. So it will have it only x here, then all over our h, still multiplying square root of x plus h in one side as a 10, then plus square root of x, then you close your bracket nicely. All right, as h approaches 0. So we continue to simplify. So we go to that here is positive x, so the negative side cancels the positive one. So we are going to get h as the numerator. So it becomes length as h approaches 0. We have h here divided by h multiplying square root of s plus h plus square root of x. Then close it nicely. All right. So we can now simplify. Since h is common to the two terms here, we can divide this by this. So we are left with 1 as the numerator. So we have length as h approaches 0. Then we having 1 as the numerator all over square root of s plus h plus square root of x. So now we can substitute the value of h into the expression or into the simplified function. So we are going to get 1 here in the numerator. So we have square root of x plus 0 representing the h, then plus square root of x. So this becomes 1 divided by square root of x plus 0. X plus 0 is x. So we are going to get square root of x here plus another square root of x. All right. So you could say that the denominator has like sets. The sets here are like. So the coefficient of this set is 1. Here too is 1. So since they are like set, we add their coefficient. So this will give us 1 divided by 2. So we add 1 to this one, while we are going to get 2. So it's going to be 2. Then you repeat one of them. So it's going to be 2 multiplied square root of x. All right. So you can equally rationalize your final answer. So if you want to rationalize it, it's going to be, you repeat the answer 1, 2 multiply square root of x. Then you use the conjugate to multiply it. So it's going to be 2 square root of x over 2 then square root of x. So this will give us the numerator multiplying 1 will give us 2 square root of x, and the down one will give us, so 2 multiply 2, we are going to get 4. Then the x squared, square root of x times square root of x will give us square root of x squared. So the square cancel the square root. We'll be left with, and the square cancel the square root, we'll be left with 2 still as the numerator as 2 square root of x divided by 4x. So which we can still simplify, because 2 divides 2 here, we get 1. 2 divides this one, we get 2. So we are going to get, we can still simplify to get it as square root of x over 2x. Square root of x over 2x. Thank you for watching.